Hi guys, yeah, welcome back to my channel. Today we'll be looking at calculation of electrolysis. For those students out there preparing for Jamb 2024, this video is for you. So, what do you understand by the concept of electrolysis? Electrolysis is the chemical decomposition of a substance either in molten form or in a solution by the passage of electric currents. But our main objective for today class based on calculation of electrolysis, and for us to be able to explain more on that electrolysis based on the calculation aspect, we are going to look at the first Faraday law of electrolysis, which we have many formulas under it, and there are some formulas I'll be showing you guys that many of you out there are not exposed to at all. So class, so first, so according to the scientists, they say that first law of Faraday states that the mass deposited or liberated during electrolysis is directly proportional to the quantity of electricity passing through it. So class, so you can say we have mass directly proportional to the quantity of electricity. So our Q, we can easily take it to be what? IT. So with that, I said M is equal to IT. And there's what we call the Z. In some textbooks they use Z, while some use capital letter M. So this Z will come in place of this. So we have an M is equal to ZIT. So listen to the terms. This small letter M is a mass. This Z here stands as the chemical equivalent of a substance. This I here is the current in ampere, and our T is time in second. So the other formula which I said I'm going to expose you guys to is we have mass over molar mass equal to IT over CL. We also have N is equal to Q over CL. Mind you, our IT is the same thing as what? Q. And our Q here is the same thing as what? IT. Are you with me now? So class, these are the formula which we are going to play with using some parameters in this electrolysis. And mind you, our F here, as we all know, is 1 Faraday is equivalent to 96500 coulomb per mole. So how do we deduce our C? In some textbook, you can find this C as N also. So class, if for example I have aluminium and the oxidation number of aluminium is 3. So this 3 here, we're having 3 plus here, that will be plus 3E, we're having Al. Then if you have sodium plus E, then if you have an element like oxygen, the oxidation number of oxygen is 2 minus. So 2 times 2 here, with this sign will give us what? Minus 4E. If you look at those elements here, for aluminium and sodium, they are carrying what? A positive sign. So I'll be showing you some kind of equation that Jamb always play with very well. So we have this oxygen gas. Then this one is moving to the other place, we are having what? Plus 4E electron. The same thing is applicable to chlorine. So negative, we have 2 here. This will give us minus 2E. We have the sign here, so we have a chlorine gas. The next one is, so if you have to write this in, we'll be having 2 moles of chlorine. We have Cl2. So now, how do we deduce the Faraday? The number of electrons you have here, that C, the terms for that C is what? The number of charge on each of the elements. 3 off. So that's 3 Faraday. Here we have what? 1 Faraday. Here we have 4 Faraday. And here we have 2 Faraday. No. Okay. Yes. So, as well, okay, for example, we also have what? Silver, Ag. The sign for this one is positive 1 plus E negative. So here we have to be what? 1 off. As I've said earlier, that for this equation you are having here, these are the illustration for most of the elements Jamb always make use of. Okay. Another one we have copper 2 plus 2E, we have Cu. So here we are having 2 Faraday as well. So guys, now we'll be looking at 10 different questions under this calculation of electrolysis, but I'll be playing with 8 and I'll drop 2 for you to what? Play. And before we look at this question, I want to advise those students out there that for every calculation in chemistry, not only for electrolysis, but if you are doing any calculation in chemistry, the only thing you have to understand is calm your nerves, because the calculator will be given the screen calculator, not the scientific calculator. So to make it short and brief, for those of you out there that are looking for shortcuts on how to solve electrolysis question, the question is good. So we have the amount of current that will deposit to 1.60 gram of silver in 72 minutes. So the first thing is, I gave you guys illustration of how you can easily write out the equation of each element. So, and I guess I show silver because there are some elements that Jamb always play with every year. So I have Ag, and the oxidation number of silver plus 1. So we have plus E, then we have what here? Ag here. Don't forget, I said if you have something like this, you have what? 1 Faraday. So now, I said you have the mass is equal to 21.60 gram. We have molar mass is equal to, we have 108. Then the time, we have 72 minutes. This 72 minutes is equivalent to 1 hour 12 minutes. So now we have to convert this back to seconds. So this is how it goes. So we have 1 times 60 minutes make what? 1 hour. Multiply by 60 seconds make what? 1 minute. Plus 12 times 60 seconds. So we have 60 so you guys can see, so we have So we have 4,320 seconds. So guys, looking at what you have on the board now, you have all the parameters out there. So go back to the formula I gave when I was showing the first Faraday law of electrolysis, which is what? Mass over molar mass is equal to IT over CL. So with this now, what is our mass here? Or before you can input the parameters, I would advise you to cross multiply. And don't forget that we are looking for current in ampere. So with that, I can say that I have what? Mass times C times F is equal to molar mass times I times T. So now, for you to make this I the subject of formula, divide both sides by molar mass times T times T. This cancels this. So we have I. So I'll be using small letter M for mass and capital letter M for molar mass. So with that, you can say that I have mass times C of over molar mass times T. So what's our mass? We have 21.60 multiplied by the C is the charge, which is what? 1 times 96500 divided by our molar mass is what? 108 multiplied by the time. So you can see we have 84. Point 08. So we have 4.467. And as a Jambites, when you look at the options you have here, these are our D and C. So we have 4.467. If you are to approximate this, so we'll be having 4.47 ampere. So class, as you can see, we have 4.47 as C. So C is your answer. So now, if when you look at these particular steps here, you see that after writing out the parameters, to have your answer, we what? Very simple. And mind the way you approximate. I repeat, mind the way you what? Approximate, because when you approximate wrongly, when you look at this now, some students might decide to pick this or this. Are you with me now? So guys, let's go to the number 2 question. The number of Faraday required to deposit 156 grams of potassium from its salt. This one is very simple and short. So now I can say potassium positive, the equation first. So I can say we have what? 1 Faraday. So I can say 1 mole, 1 Faraday require 1 mole of potassium. So now half mole of this will give us, so we have this potassium, so that will be, this question is not complete. This question is incomplete. So we're moving to the number 3 question. So calculate the quantity of electricity in columns required to deposit 12.22 grams of silver salt. So class, if you have to look at the number of what? The quantity of electricity in this. So it's very, very what? Simple. The same formula I'll be using since. So our silver is what? Ag. So to have our quantity of electricity, so you can easily say we have mass over molar mass is equal to Q over CF, instead of using our IT, because we are asked to look for the quantity of electricity. So what's our mass here? Our small letter m is 12.22 gram. Then our molar mass, we have it to be 108. Then what's our C? 1. So our C is what? 1. Then we all know that our F, which is 1 Faraday, is constant. So with that now, just cross multiply. We can see we have, that will be small letter m mass times C of is equal to capital letter M Q. So with this now, we have to make this Q the subject of formula. So we have Q here. We also have what? Q here. So, sorry, M and what? M here. So our Q is equal to M times C of over what? Molar mass. So our mass, we have 12.22 gram multiplied by our C 1 times the Faraday constant. Then our molar mass is 108 gram per mole. This we cancel this. Mole we also what? Cancel mole. And don't forget that we have to what? Calculate the quantity of electricity in what? Coulombs. So this C here is our coulomb. So it's very simple, class. So multiply the numerator together and divide by the denominator. So I can say I have 2.22 multiplied by 96500 times, sorry, 2.22 times 96500. So we have 1179230 divided by coulombs 8. Okay, no option for this. So with that, I can say we have 10918.7. So if you are to coulombs, if you are to approximate this, you can say we have what? 109. So coulombs. So please, one thing about Jamb is they are very well tricky. So you can have this as the answer, and you can as well as this as the answer. So I will advise you have to what? Go with this. But if when you point your calculator at the end, you have it like here we have, you can see we have 10918.79. So for Jamb now, if we are having 9 here coulombs, so if I have to approximate, then it will be 1091.8.8 coulomb. But if I'm only having what? 10918.7. So our approximate will be what? 10918. Sorry, 10919 instead of what? 10918. So guys, when it comes to electrolysis, there are some approach to it. You don't just like look at the question and you assume the answer that okay, this should be the what? The answer. So the next one is, what mass of copper will be produced from 0.5 Faraday of electricity? Again, what mass of copper will be produced from 0.5 Faraday of electricity? So looking at this kind of question, the first thing we are going to do is we have to draw the equation of copper. So if this is our copper, 2 plus 2E, we have Cu. So now we are having 2 Faraday here now, and here we have what? 1 mole. Said 2 Faraday require 1 mole of copper. Then 1 Faraday require 1/2 mole of copper. And if you are to point your calculator, this half here, 1 divided by 2 give us what? Is equivalent to what? 0.5. And look at what you have here of electricity. So what you're going to do is that, say the molar mass of copper is 63.5. So we have so this is what you're going to do. That will be this multiplied by molar mass of Cu. So that will give us 0.5 multiplied by 63.5. So by doing that, we have 31.75. So let's take a look at if we have something like that. So you can see the other. Look at this number 5 now. What current in ampere will deposit 2.7 gram of aluminium in 2 hours? So the first thing I'm going to look at is that you have to draw the equation of aluminium, which is this. So we have Al. So don't forget the formula we are using. So mass over molar mass is equal to IT over CL. So class, what is our mass? Our mass is 2.7 gram. Our molar mass of aluminium is 27. The current in ampere. So we have to look for the current. So the current is unknown. See, 2 hours. So with this, I'm going to say we have 2 times 60 minutes multiplied by 60 seconds. So with that, don't forget, I told you guys earlier that you are not going to be given a scientific calculator. So we have 2 times 60 times 60. So we have this. So now, go back to the equation we have here. This 3 is the same thing as the C. Why our F, same thing as what? Faraday constant. So with that now, we are going to look for I. So when you cross multiply, you'll be having molar mass multiplied by I multiplied by T is equal to mass multiplied by C multiplied by what? F. So we have to make this I here the subject of formula. So with that, we can say we have this. So our I, so we have in what's our mass? 2.7 multiplied by gram. Our C is 3 multiplied by 96500. Don't forget the units. Column per mole. Divided our molar mass is what? 27 gram per mole. Go back to this place now. Here, when Jamb is giving you the equation, nothing like the units here. So our unit for molar mass is gram per mole. So multiply by the time in seconds. So the more we cancel this, the gram we cancel this. Hope you are saying it. So you can say we multiply all through for the numerator as well as the denominator, then we divide. 2.7 multiplied by 3 multiplied by 96500. And so we have 781,650 divided by 27 times 72. So we have so you can see we have 781,650. So now our answer here is 4.029. So let's go back to this place. You can see we are having 4, we are having 8, we are having 32. Now if we are to approximate now, you can see we have 4.03. So the significant figure, we are going to have what? 4.0. Are you with me now? So let's go back to this now. So our answer is what? We are having C as our answer. So let's quickly look at this number 2 equation. The number of Faraday required to deposit 156 gram of potassium from its source is, so if you have to solve a equation like this, it's very what? Simple. So this K here stands for potassium, and the atomic mass of potassium is 39. So now A, we have 2 Faraday, B, we have 4 Faraday, C, we have 6 Faraday, and D, which is the last option, we have 8 Faraday. So from this now, I'm going to show you guys a simple way, or let me just say shortcuts, because most Jambers out there are looking for what? Shortcuts. So we have 159 gram of potassium, and the molar mass of potassium is given to what? 39. So it's very what? Simple. So we are looking for the number of Faraday. I will just simply do it like this. N is equal to mass of potassium divided by molar mass of potassium. So the mass of potassium is 159 gram. So we have what? 39 gram per mole. So this cancel what? This. So let's take a look. So we have 159 divided by 39. Sorry, is 156. So we have 4.076. So when you approximate this also, so I'm going to have what? 4. So this. So now let's go back to this place. Now we're having what? Say 4. So you are going to add your what? 4 Faraday. So from the question that states the number of Faraday required to deposit 159 gram of potassium from its source is 4 Faraday. Now this is the 6th question. So a current of 4 ampere was passed through copper tooth tetraoxosulfate 6 solution for 1 hour. What mass of copper was what deposited? Now we have to look for the mass from this formula. Capital letter M, formula mass, don't forget, we have IT over C of. So class, our copper 2 plus, so E, Cu. So our small letter M is a mass, which we are looking for. The molar mass of copper is 63.5. Our I is 4 ampere. Then our T, we have 1 hour. So now, if you're having this 1 hour, so that will give us 1 times 60 minutes multiplied by 60 seconds. So to have that now, we are going to multiply what you have. So we have 1 multiplied by, so we have this seconds. So our C here is 2. Then our F, we all know, is constant. So with that, let's cross multiply and look for our mass. So we have M mass C of is equal to molar mass times I divided by T. So divide both sides by C of. So this cancel this. Our mass is equal to, what's our molar mass? We have 63.5 multiplied by 4 multiplied by this, divided by 2 multiplied by 96500. Don't forget I said our C is always the charge, which is what? 2. So with this now, this cancel this cancel this. So you are going to multiply the numerator and divide what with the denominator. So with that, it says 63.5. So we have 9144. So 2 times 965. So now, so we have M is equal to 4.73. So now, let's go back to the option. You have something like 4.73. You can see for Jamb, we're having 3.2 gram, 48, and here you have what? 4.8. So when looking at the calculator here, what we're having here is 4.737. So the correct answer here is what? This. Are you with me now? So we have our answer to be what? M is equal to 4.7 gram. So we are going for what? This. So if you look at what you have on the board, we are using the same formula and the same method. So for those of you looking for shortcuts out there to solve your electrolysis, so I'll be stopping the class here. So I want you all to practice this as a Jamb bite. Go to 2021 question 12 as well as 2021 question what? 22. You know, earlier I told you guys that for every electrolysis, there are some elements Jamb always play with. The likes of copper, aluminium,